Hi, good morning, everyone, and welcome to another weekly Q&A webinar with Big Switch Networks. This is Sunit Chauhan, Head of Product Marketing here at Big Switch, and I will be your host for today's webinar. As we do every week, let me quickly go over some of the housekeeping information, and then we'll get started. We have a really exciting topic lined up today. The only thing I'd like to mention at this point is that if you have any questions while the webinar is going on, I highly recommend that you go to the question answer dashboard on your webinar dashboard and ask a question there. If you're watching this webinar in a rebroadcast, you can always go to bigswitch.com/webinars and submit a question using the box provided there. So with that, and without any further ado, let me introduce the topic and the panelists for today. Today we continue our Partner Alliance, Technology Alliance Partner Series, and we have a guest speaker from F5 Networks. We're joined today by Matt Quill, Business Development Manager at F5 Networks. Welcome, Matt, and thank you for joining us.
Thanks, great to be here.
Awesome. We're also joined here in the room. I have Bala Ramachandran, Director of Product Management at Big Switch Networks. As many of our regular attendees know, Bala runs our Technology Alliance partnerships, in addition to some other responsibilities on the product management side. So welcome, Bala.
Thank you, Sunit.
And we also have on the line Ganpati Bhatt. Our regular attendees will know that Ganpati has done a whole lot of demos for us, but today he's remote, but he's, as usual, recorded a demo for us. And at the end of the presentation today, in addition to going over the topic for discussion, we will also have a demo recording that we will play. So the topic today is something that is very, very interesting, and that has to do with automating application delivery services, load balancing with our SDN fabrics. So today what we're going to do is talk about F5 load balancer, F5 application delivery services, and how it works with the Big Switch's Big Cloud Fabric controller. So with that, Bala, let me hand it over to you, and why don't you kick us off?
Thank you, Sunit. Good morning, everyone. So let me start off with a brief overview of Big Cloud Fabric. So Big Cloud Fabric, or BCF, is the industry's first SDN-based data center fabric solution, which is built with open networking switches. It's a leaf-spine cloth fabric, providing physical and virtual workload connectivity within a data center pod. So to the left of this picture, you'll see the Big Cloud Fabric controller, where the fabric configuration, automation, and troubleshooting can be achieved through a single pane of glass, offering tremendous operational simplicity. So while most of the fabric intelligence is in the controller, some of it is judiciously offloaded to the SwitchLite OS, which is a thin OS which runs on each switch in the fabric. So this enables resiliency and scale of the fabric. The Big Cloud Fabric controller also acts as a single point of integration with cloud orchestration systems such as OpenStack. In addition, for vSphere workloads, it integrates with the VMware vCenter to automate network creation on the physical SDN fabric. So we talked about the controller. The leaf and spine switches in the fabric are dense 10 gig, 40 gig, bright box or white box switches that we support from vendors such as Dell and Acton. Now, redundancy is built in throughout the fabric across the switches and controllers to ensure no single point of failure. So by leveraging open networking hardware with our resilient software, it really helps us deliver a very cost-effective production-grade solution, a solution that is delivered as a complete integrated package with a single point of support. Now, BCF makes deploying applications really simple with configuration based on tenant-centric logical networks. It helps achieve application agility with seamless insertion of layer 4 to layer 7 services such as load balancers and firewalls, as well as enable service chaining. So for our discussion today, we'll focus on how F5's BIG-IP can be seamlessly deployed to offer load balancing services in Big Cloud Fabric. So Big Cloud Fabric now supports VMware vSphere server virtualization by delivering the benefits of OpenSwitch hardware and SDN to VMware environments. So the controller directly integrates into the VMware vCenter to automate network application deployment on the physical SDN fabric, and this integration enables VM visibility, including VM mobility, directly through the BCF controller GUI. So the solution that you see here is composed of F5's BIG-IP deployed with BCF for VMware environments. So within the BCF pod, the BIG-IP can be deployed in multiple form factors: physical appliance or virtual appliance. The appliance can be deployed as a dedicated service or as part of a service chain. The BCF supports the ability to create logical tenants that can span multiple physical racks. As part of this logical architecture, the F5 device can be configured to load balance either client-server, which is north-south traffic coming into the fabric, or server-to-server, which is the east-west traffic within the BCF. And it is deployed as an endpoint in the fabric, and traffic is forwarded based on the layer 3 virtual IP address of the ADC. Physically, BIG-IP can be attached to any of the leaf switches in the fabric. So a demo of this solution will be presented later in this webinar. Now, talking about OpenStack environments, we have this joint BCF F5 LBaaS solution, which offers complete end-to-end L2 through L7 automation. Firstly, network creation is automated with a BSN ML2 driver mechanism. As networks are configured by the OpenStack admin, the Neutron service invokes the BCF controller through the REST APIs to dynamically provision them on the BCF. In addition to this automation, BigSwitch has provided enhancements to the Horizon dashboard, which enable application teams to automatically create networks with predefined and pre-approved heat orchestration network templates. This, along with other enhancements to Horizon for troubleshooting, offers tremendous operational benefits to the application tenants leveraging the solution. Now, F5's load balancing as a service can be enabled in this environment with a cloud admin installing the F5 LBaaS drivers. While the management of the appliance is handled by the cloud admin, tenants can manage their load balancing application-specific config by creating the pools, WIP, which are needed for their load balancing service. Note that with this solution, both physical virtual appliances can be deployed in standalone or HA mode, and multiple instances of it can be deployed for scaling purposes. Thus, the joint solution offers a very efficient and a completely automated way for OpenStack users to deploy applications without using long and drawn-out trouble ticket processes to get their networks deployed for their applications. Ganapati will be presenting a hands-on demo of this solution later in this webinar. So what are some of the key value props of the solution? So the first thing is agility. The application-centric multi-tenant architecture of BCF enables each tenant to have administrative control over logical layer 2, layer 3, and policy design. And within this multi-tenant infrastructure, the F5 appliances can be leveraged for dynamic layer 4 to layer 7 service insertion as well as service chaining at a tenant level. Thus, this enables agility in application deployment. The second key aspect is simplicity and scalability. So the most unique value prop of the BCF solution is fabric-wide operational simplification. Zero-touch installation, automated fabric bring-up, centralized configuration of tenants and logical router segments, fabric-wide rapid upgrade, and seamless insertion of layer 4 to layer 7 services such as F5 ADC. The operational simplicity of the solution also stems from the fact that there are no complex networking protocols running in the fabric, and this enables seamless scale-out of spine and leaf switches in the fabric. With F5's flexibility of service deployment, the layer 4 to layer 7 services can be easily scaled along with layer 2 to layer 3 in the fabric. So thus, the solution offers great operational benefits and also enables elastic scaling of applications. And finally, the economics of the solution. We talked about how the model of disaggregation of hardware and software provides great flexibility and avoids vendor lock-in, thus offering dramatic cost advantage. Combining this CapEx reduction with the operational benefits, the solution offers tremendous TCO reduction to our customers. I'd now like to turn it over to Matt, who will talk in detail about the F5 BIG-IP benefits and how it can be leveraged in SDN environments.
So my name is Matt Quill, Business Development Manager for F5. I've been with F5 for about 5 years. If you could just flip to the next switch. I'm going to do an introduction for those of you who are unfamiliar with F5 and its uses in the data center or outside of the data center. Basically, what F5 does in its very simplest terms is we connect users to applications. We do so in a highly available, fast, and secure manner. We extract away a lot of the complexities of different environments, whether that's on-prem physical deployments, virtualized deployments, private clouds, public clouds, or SaaS environments. We can sort of abstract away a lot of the complexities and sort of allow you to access your applications in a secure manner, whether that's on-prem or off-prem in an existing cloud. And what we also can help you do is as far as plugging into a lot of these SDN and automation frameworks, including OpenStack, we can allow you to sort of enable a DevOps type workflow so that you can rapidly provision applications, apply services in concert with Big Switch, and then sort of test and develop your applications in a rapid cycle. So from an application services platform, F5 provides both physical hardware. Our hardware starts from our plastic, 1U appliance-based chassis, appliance-based products, all the way up to our chassis-based products, which have multiple blades and can scale up to a terabyte of throughput. We also have virtual editions of our products, which are widely sold and widely available. We support all of the major hypervisors out there, from Xen to VMware, and we can support very, very high performance, so up to 10 gigs of throughput on our virtual editions. So there's a lot of flexibility in how you can deploy our product. There's also a flexibility in how we provide licensing for different data center, whether it's a dedicated environment, a private cloud, or a cloud environment, or a combination of the above. We have a cloud licensing program that provides an utility or annual subscription model. We have bring your own license. So for example, if you're running steady state in the cloud, you may realize that a bring your own license model is more cost effective. Or we have subscription-based licenses on large volume purchases of our product. So there's a lot of flexibility in how you can sort of provision, deploy, and recycle your virtual editions so that you can provide services to your applications in a very dynamic, very fast manner. We've also plugged into a lot of the DevOps frameworks, most specifically Puppet, and have integrated with all of the leading SDN vendors, including, most importantly on this call, our partnership with Big Switch. So I want to talk just briefly about our history of OpenStack. We've been involved very intimately with the OpenStack community since 2011. We joined the consortium in 2013 and have been contributing development resources on a regular basis. In May of 2014, we released our first LBaaS, community-supported LBaaS plugin, which can be found at devcentral.f5.com. And we've made substantial updates since then. Our goal, as far as the LBaaS plugin, is to sort of be in lockstep with each new release of OpenStack. We're not there yet. There's a bit of a lag, but we support Juno, and we'll be supporting Kilo very, very shortly in this month, in fact, and plan to also support successive branches of OpenStack for our LBaaS plugin. This LBaaS plugin is freely available. If you go to devcentral.f5.com and have an OpenStack project, it's important that you can start sort of doing your test and development with F5 integrated in via the Horizon UI, deploy and provision F5 services. One of the challenges that we're finding with OpenStack is that we are trying to sort of develop, but also kind of push the development forward of our LBaaS plugin and other plugins, for example, firewall as a service, DNS offerings, and things like that, that make OpenStack a mature platform. However, as it currently stands, a lot of our value as an ADC, application delivery controller, is not yet available in OpenStack as a platform. So when we plug into LBaaS, there is a substantial additional value that you run. Things like SSL offload, multiple availability and monitoring algorithms, multiple load balancing algorithms. A lot of those are not yet available. So just an overview, one of the things that we find is that you have, from a load balance perspective, you have two on OpenStack, so two different load balancing methods, and 32 different load balancing algorithms on the BIG-IP health monitors, or there are 32 different health monitors on the BIG-IP. We support a lot of the different enterprise-level applications. And so what we're working, or our position as far as OpenStack, is that we're working very aggressively with the OpenStack community to help drive a lot of these features that make the OpenStack platform an enterprise-ready or cloud-ready deployable platform, so that a lot of the value that F5 brings to the table for our customers, it's the reason why we have such a dominant position in the marketplace, can be exposed via the OpenStack platform, and F5 can programmatically integrate into that. What we've also done with Big Switch is we've gone through and integrated with Big Switch as one of the leading SDN vendors, so that the process of deploying OpenStack is much more simplified and much more automated. So with that, I will sort of turn it over for the demo. Thank you very much.
The demo plan is to showcase the deployment scenarios of Big Cloud Fabric with F5 BIG-IP as a server load balancing service. First, I would showcase how BCF and F5 BIG-IP virtual appliance is deployed in vCenter environment to provide load balancing service for client-server deployment model. Secondly, I will show how BCF and F5 load balancer as a service integration with OpenStack helps tenants to dynamically provision both physical fabric and the load balancing service. Let's start with the BCF and F5 deployment in vCenter environment. On left, a logical topology for tenant blue, which is hosting 3-tier app on vCenter and Big Cloud Fabric. And each of the tier has 3 VMs distributed across the BCF on different compute hosts. I have 4 ESXi hosts, which are managed by vCenter, and vCenter integration is enabled on the BCF. And I have F5 BIG-IP virtual appliance hosted on one of the ESXi hosts. The requirement here is when a client or a user tries to reach web server from outside, the traffic needs to be load balanced across the web server instances to provide the redundancy, performance, and scale to the tenant blue web tier. Let me demonstrate this deployment. This is the vCenter web interface. This is the compute cluster I'm using for this deployment, which has 4 ESXi hosts which are connected to BCF Fabric. I have 3 VMs each in each of the tiers, web, app, and DB. And this is the F5 BIG-IP virtual appliance, which will be used for layer 4 to 7 service for the web tier. This is the vCenter networking page. I have 2 port groups already configured for blue tenant web tier and the app tier, which are on VLAN 1001 and 1002. And F5 BIG-IP is part of this vCenter port group along with the respective VMs. This is a Big Cloud Fabric controller web interface. Let's go to the vCenter integration page. I have already registered the BCF controller with vCenter. And here is the vCenter page on BCF, which provides information on vCenter, ESXi host connectivity details, and also the information about all VMs and its details, including physical location within the vCenter cluster. As you can see, blue tenant web tier VM and F5 BIG-IP info shown in the endpoint table. All this is dynamically provisioned and learned as part of the BCF and vCenter integration. Let's go to the tenant, which is dynamically created as part of vCenter integration. As you see, the logical router interface and the segments are configured for both the blue tenant tiers, web and app, which are on VLAN 1001 and 1002 respectively. Now let's create the third vCenter port group for DB tier with VLAN 1003 and add all DB VMs to that vCenter port group. Now let's look at the BCF tenant configuration. The new segment dynamically got created under BSN vCenter tenant to reflect the new vCenter port group, which is on VLAN 1003. And on vCenter integration page, it provides the details about this port group, and the VMs in DB tier associated with this port group. Just like the web tier port group and associated VM info, including VM IPs. In this case, web tier VMs have IP address of 10.2.17, 2.11, 2.12, and 2.13, and the F5 BIG-IP virtual appliance IP is 10.2.17, 2.14, and the 2.15. Now with the physical fabric and the VMs deployed, let's look at the F5 BIG-IP configuration. F5 BIG-IP is configured with virtual server, which is associated with server pools, which is associated with the web tier server IPs. More details on each of this configuration. Virtual server, which has VIP virtual IP 10.2.17.2.15 on port 80. Pool, so web pool with 3 members 10.2.17, 2.11, 2.12, and 2.30 on port 80, which are IP addresses of the 3 web virtual machine on vCenter. Here is the stats on the F5 for virtual server and individual pool members. Now let's try to access the web server using the virtual IP, which is 10.2.17.2.15. As you refresh the page, you can see this web request on the virtual IP 10.2.17.2.15 getting load balanced across all 3 web servers using the F5 BIG-IP load balancer. For the demo purpose, I have used a different font color and the web server number. In real deployment, one would see the identical web page in this similar scenario. Now coming back to the F5 BIG-IP, as you see, the stats got updated to reflect all the new web request and response it got as part of this demo. So that's about the BCF and F5 BIG-IP virtual appliance deployment in vCenter environment. Let's look into the BCF and F5 load balancer as a service integration with OpenStack. This demo has 2 parts. First, I would show how BCF integration with OpenStack Neutron networking project to build self-service model to the application developers in terms of provisioning physical fabric dynamically. Secondly, I will show how OpenStack load balancer as a service module used to automate the configuration of the physical and virtual load balancer as and when tenants enable the load balancer service on the OpenStack for their deployments. To showcase this, I plan to deploy my web application. The application has 2 segments, one for web server and the other for web client. As Project Blue admin configures these segments, routers, and the virtual machines, Big Cloud Fabric gets configured dynamically using Neutron ML2 plugin. Let's look at it. This is the OpenStack Horizon dashboard, logged in as tenant or Project Blue admin. Let's create the network topology as shown for the demo. Create 2 segments, one for client and other for web server. Launch instance and have 2 web servers and a client in the respective segments. Create router to interconnect the 2 segments. The complete network topology is shown on the screen for the given tenant. Now if you go back to BCF controller and you refresh the tenant view, it shows the tenant blue configuration just created on OpenStack Horizon. This is done dynamically through the ML2 plugin. No manual configuration involved on BCF. This is the first part of the demo to show how BCF integrates with the OpenStack Neutron to automate the OpenStack tenant workflow to configure physical fabric. Next, let me show the workflow automation for inserting layer 4 through 7 service, a load balancer, to the web application we just deployed. The pre-demo setup is, as shown on the right, I have connected the physical load balancer to the BCF fabric. And on OpenStack side, I have enabled the load balancer as a service and I installed the LBaaS driver to talk to the load balancer appliance. This is the one-time workflow as a provider of the load balancer service need to do. Once you have this set up, OpenStack tenant user can use this service to deploy automatically the load balancer service for their application from OpenStack Horizon dashboard. So to showcase the tenant specific workflow, I'll be adding load balancer service to the web servers we just deployed. To configure load balancer service, tenant admin has to go to OpenStack Horizon project tab, then network tab, then load balancer tab. Before configuring the service, let's look at the load balancer appliance web interface for the existing config. As you see, there is no configuration on the load balancer appliance. Now to define load balancer service, tenant admin need to define pool to start with. Let's call it Blue Web Pool in the web server network subnet. Select the protocol and load balancing method for the pool. Next, define members to the pool. Select define pool and members, in this case web server 1 and 2. Select protocol and port for the service. Last step in the load balancer config is to configure VIP, virtual IP. Provide virtual IP name, select subnet and specify virtual IP. In this case 10.100.1.100. Select protocol and port. This completes the load balancer config. Click on the pool name which summarizes the config. Make a note of project ID, which is used for creating tenant on the load balancer appliance for the given project. Let's go to the load balancer appliance web interface. As you see, OpenStack LBaaS service configured the appliance automatically with the blue tenant web server load balancer configuration done on the OpenStack Horizon dashboard. As you see, the VIP 10.100.1.100 on port AAT got configured. Clicking on the pool, it shows Blue Web Pool, and the members are configured with web server -1 and 2 IP addresses as Blue Tenant Admin configured on the Horizon dashboard. All this is done dynamically through the LBaaS driver on the OpenStack. No manual configuration needed. This also updates BCF, and BCF enables segment membership for the load balancer appliance interfaces and also learns VIP. Now as a last step, let me send some HTTP requests to the web server virtual IP from web client to show the load balancing of the HTTP request. I'm on web client and I'm generating HTTP requests using curl to virtual IP, which is 10.100.1.100. As you see, the HTTP request being load balanced across the web server 1 and 2, as you can make out from the output. In summary, BIG Cloud Fabric and LBaaS integration with OpenStack automates both L2 and L3 networking and also layer 4 through 7 service insertion. Thank you.
So that was great. Thanks to Ganpati for recording this webinar for us. He actually had to be remote today, so we couldn't have him give the live demo, but nonetheless, it was a very informational webinar, or a very informational demo here. With that, we are at the bottom of the hour here, so let me thank our panelists, Bala and Matt Quill. Thank you both. Really appreciate you guys taking the time today. This concludes our presentation for today, but if there is anything that we discussed today, or there are questions on how the integration works between F5 BIG-IP and BIG Cloud Fabric from Big Switch Networks, please reach out to us. All of our past webinars, including this one, will be posted online, and you can get to those by clicking on our homepage, getting to the homepage, or you could directly go to bigswitch.com/webinars. If you want to try out our products, both BigTap Monitoring Fabric as well as BIG Cloud Fabric, the one that we discussed today, please sign up to get free access to our online lab at labs.bigswitch.com. And last but certainly not the least, we have starter kits, a number of starter kits actually now for both BigTap as well as BCF. So starting at a list price of $29K and $39K, these starter kits come with all the switching hardware, software support, cables, that make it really easy for you to implement your very first SDN-style data center pod. Over the next couple of weeks, we will be taking a break here, end of summer. So we are seeing a lot of our folks here in the office taking some time off to recharge. But we do have a very exciting set of webinars planned when we come back from this break. So on the 19th of August, when we come back, we have a very interesting webinar lined up. You should receive emails on how to register for that webinar in due course, in a couple of weeks maybe. On the same day, we will, at Big Switch, we will also be hosting Networking Field Day 10. So that is when our PLM team, our CTO, our executives actually give a live demo broadcast. It's a couple of hours where we will have a number of bloggers and technology analysts here in our office. And there will be a live presentation of all of the new functionality that we are adding to BCF as well as BigTab. So I hope everybody can join that, and we will send out the invites for that webinar as well as the NFT 10 presentation in a week or so. This concludes our presentation for today. Thank you all, and have a great rest of the week.